Let's look at a test for determining limits from a formula. This is called the Epsilon-Delta test. And the epsilon and delta here are just the Greek letters. And we're going to use these as variables in the test for limits. These are just sort of the traditional symbols that we use. First, I'm going to perform this test with a very simple function whose limit we can already calculate. My function is going to be f of x equals just x. And I want to calculate what is the limit as x approaches 0 of the function x. From my previous lecture, the only tools we have right now are graphical tools. I can draw a simple graph of this function. Again, my lines aren't very straight, but this will do. And the question is, as x gets closer and closer and closer to the coordinate x equals 0, coming in from the left and from the right, is there a singular destination in the y coordinate? So as I approach from the left, it appears that my y coordinate is going to 0. From the right, my y coordinate is also coming closer to 0. So I can say, because the one-sided limits exist, and they agree, then the limit that I want, as x goes to 0 of the function x, this must be equal to 0. Now, I don't want to draw a picture every single time. I would like to be able to use algebraic reasoning. So I'm going to go back to my previous idea about following the moving pendulum. How did I know that there is a limit to the motion of the pendulum? How do I know that there is a destination, even if it overtakes and goes too far and comes back, overtakes in the other direction, and so on? In my previous videos, I was talking about the deviation, right? I can imagine what that destination should be, and even if I overtake it, the amount that I deviate by is shrinking as I get closer and closer. So graphically, you can see that I'm just zooming right in. Both sides of the function approach the same limit. Algebraically, though, I want to know how far is the y coordinate from the final destination. So that's part of my reasoning. And I also want to know if we are close enough in the x coordinate, does this force the y coordinate to be closer to the limit?